Hey guys, welcome. Today we're going to go over review of proportional relationships from tables, and then we're going to also look at one from a graph. Okay, so which table shows a proportional relationship between x and y? And just remember on these questions, there could be more than one correct answer, but not necessarily. So let's start out with table 1. To see if there is a proportional relationship, we're going to divide y over x. Okay, so in our first table, our y value is 5 and our x value is 2. So we can't simplify that 5 halves. Let's look at the second values in table 1. Our y value is 10 and our x value is 4. But that one can be simplified by dividing by 2. So 10 divided by 2 is 5 and 4 divided by 2 is 2. So we get 5 halves. And then let's check the last one in table 1. We have the y value of 20 over the x value of 8. And those can be simplified by dividing by 4. So 20 divided by 4 is 5. And 8 divided by 4 is 2, which also simplifies to 5 halves. So all three of our y over x values were 5 over 2. So that tells us that table 1 does have a proportional relationship. Now we also need to check our other table, table 2, and we'll do that as well by doing y over x. So our first y value is 2 over our x value, which is also 2. And 2 over 2 is equivalent to 1 whole. Also in table 2, our second y value is 8 over 5, which cannot be simplified. So we have 1, and then we have 8/5. There's really not a need to keep going at this point because all three values in the table would have to be the same for that to be proportional. However, just for the practice, our other y value is 18 over 10, and both of those are divisible by 2. So 18 divided by 2 is 9, and 10 divided by 2 is 5, which is 9/5. So as you can see, 1, 8/5, and 9/5, those are not equivalent. So table 2 does not have a proportional relationship. Okay, let's review proportional relationships by graphing this time. Okay, it says the big box store, Cost Club, hires Denise to replace its broken light fixtures with new energy-efficient LED lights. Denise charges a service fee to come to the store, plus an additional fee for each light fixture replaced. If Denise replaces 2 light fixtures, she charges the store $60. If she replaces 4 light fixtures, she charges $100. In this relationship, X represents the number of light fixtures Denise replaces, and Y represents the amount of money she charges the store. So let's highlight some of those important things that we're looking for. So she's replacing 2 light fixtures, and she's going to charge $60 for that. When she replaces 4, she charges $100. Okay, so let's think about what those values or where those points are going to go on our graph. So 2 light fixtures, that's on my x-axis. So I'm going to go over to 2. And then that would cost $60. So I'm going to go over to 2 and then up to 60. Okay, then we want to look if she replaces 4 light fixtures, she charges $100. So I'm going to go over to 4 on my x-axis and up to 100. And now I need to get me a straight edge, so get your straight edge if you haven't already. And I'm going to connect those points. Okay, so to see if a graph is proportional, we talked about two things that must happen. For one, our line has to be straight. That means no curves in it at all. And looking at this graph, our line does appear to be straight. However, it also has to pass through the origin. So remember the origin is down here at 0, 0. Okay? And do we see anything at 0, 0? No. So our line did not pass through the origin. So if it does not pass through the origin and a straight line, remember it has to be both, then it does not represent a proportional relationship. So for this one, our question says, according to the graph, do x and y have a proportional relationship? In this case, no. And why is that? Because in this particular graph, it does not pass through the origin. It is a straight line, but it does not pass through the origin.